Okay, so in the last lecture we have started the concept of heat engine, refrigerator and heat pump. So out of that we have seen what is meant by heat engine and what is meant by refrigerator. So heat engine is nothing but the device which can produce the work by transferring heat from higher temperature region to a lower temperature region. And efficiency of heat engine is given by equation. Efficiency is equal to Q2 minus Q1, which is equal to W divided by Q2, whereas Q2 is called as the amount of heat supplied and Q1 is called as the amount of heat rejected from the heat engine. And refrigerator is called as the reverse of heat engine. Why we are calling it as a reverse of heat engine? Because exactly reverse procedure is occurring inside the refrigerator. Exactly reversible means in case of heat engine, heat flow of heat is from higher temperature region to the lower temperature region, and during this flow of heat there is a production of work. Whereas in case of refrigerator, the flow of heat is from lower temperature region to higher temperature region, and according to Clausius statement, to occur this uh, uh, flow of heat from lower temperature region to higher temperature region, we have to supply the work. That's why refrigerator will be called as a work consuming device. So in the last lecture, we have completed up to here. Now here, if I want to calculate the COP of refrigerator, if I want to calculate the COP of refrigerator, how can I calculate the COP of refrigerator? As we are knowing that COP is nothing but a ratio of what we get to the what we pay. That means output to the input. So here, what is the output and what is the input? What is the desired output? Can anybody tell me what is the desired output in case of refrigerator?
Heat absorb.
How much amount of heat is being absorbed from a body which we want to maintain, or whose temperature we want to reduce and maintain. So here Q1 is nothing but amount of heat absorption. So here in case of refrigerator, our main intention is to keep the temperature T1. Main intention is to keep the temperature T1 less than atmospheric temperature. That is our main intention in case of refrigerator. So here our main focus will be on the low temperature body, that is nothing but T1. And for that, how much amount of heat absorbed, how much amount of heat is being absorbed from a substance which you want to cool, that is called as a desired output. That is called as a desired output. And to obtain this desired output, what input we are providing? Here we are providing the input as a W. Until and unless we are not providing the W as an input, until and unless there will not be the electricity supply, that fridge will not start, or the water stored in the fridge will not get lower temperature. So here, until and unless W will not be provided, Q1 will not be absorbed. So here Q1 is nothing but amount of heat absorbed, that is also called as a refrigerating effect, and W is called as the work done. So as we are knowing the formula for COP is nothing but output upon input. So desired output is nothing but amount of heat absorption, that is nothing but QA, and divided by input is nothing but work done, that is nothing but work done on refrigerator. If I'm mentioning this as a WR, work done on refrigerator. So Q1 upon WR is nothing but the COP of refrigerator. Now here, if I am providing W as the amount of work on the refrigerator, then according to first law of thermodynamics, that work will get converted into heat, and because of the same, the amount of heat rejected from the refrigerator will have the higher value as compared to the amount of heat absorbed. So here value of Q2 will be equal to Q1. Value of Q2 will be equal to Q1 plus W. So here, by using this equation, if I want to calculate the value of W, what will be the value of W? Value of W will be equal to Q2 minus Q1 by using this equation. Q2 is equal to Q1 plus W. So here value of W will be equal to Q2 minus Q1. So here, if I am going to put the value of WR, work on a refrigerator, as a Q2 minus Q1, so I will get the final formula for COP of refrigerator. So value of COP of refrigerator will be equal to Q1 divided by Q2 minus Q1. Here Q2 minus Q1 will be inside the bracket. That can bracket राहिलाय. फक्त mention काय करायचं? Divided by in bracket Q2 minus Q1 bracket complete. That will be the value of COP of refrigerator. Are you getting? समजला concept refrigerator चा? Yes or no? काहीतरी सांगा. Yes,
Yes, sir.
or no? Okay. Now next concept is called as a heat pump. So heat pump, can anybody tell me related to the heat pump? What is in the heat pump? Sir, you can tell. What is the difference between refrigerator and heat pump? Unmute yourself and tell. Sir. Anyone else?
Sir,
हाँ,
heat pump.
बोला बोला. बोला. Sir. Your voice is not clear. Sir. Thakre. Can you tell the difference between refrigerator and heat pump?
Yes, sir.
हाँ.
Heat pump extract heat from lower temperature to high temperature
Lower
with
temperature to high temperature
external work.
with external work.
Uh,
No. Who will tell the exact difference? Abhishek Shinde. Avtade. Unmute yourself and tell.
It is a device to transfer heat from colder area to hotter area by using mechanical energy.
In case of refrigerator also, we are doing the same. It is absorbing the heat from lower temperature body or cooler area, and it is being rejected to the higher temperature body, that is nothing but hotter area. And here also we are providing the mechanical work.
Yes.
It means whether refrigerator and heat pump are one and same.
Hello.
Whether refrigerator and heat pump are one and same. दोन्हीमध्ये काय बेसिक डिफरन्स काय आहे कोणाला माहिती आहे का? माहिती आहे कोणाला? येस और नो?
Hello, sir.
हां बोला.
A refrigerator is a work consuming device and a heat pump is work producing device.
No. Heat engine is a work producing device, not the heat pump. In another?
Sir, high temperature to low temperature असेल
बहुतेक
बहुतेक नाही आहे असं माझ्या लक्षात नाही आलं पण आहे.
वाटतंय.
नाही नाही आहे. हीट पंप त्याच्यासाठीच आहे.
So here afterwards you have to keep in mind that there is a no basic difference, or there is not having any difference between refrigerator and heat pump in case of cycle of operation. In case of cycle of operation, only difference between refrigerator and heat pump is the intention difference. What is the difference? Only intention difference. That means what is the intention in case of refrigerator? आपले इंटेन्शन काय असतं रेफ्रिजरेटर मध्ये? रेफ्रिजरेटर मध्ये आपले इंटेन्शन काय असतं? T1 इज लेस दॅन TA. म्हणजे त्या ठिकाणी लोअर बॉडीचं टेम्परेचर जे आहे, लोअर बॉडीचं टेम्परेचर काय पाहिजे आपलं? ॲटमॉस्फेरिक टेम्परेचर पेक्षा कमी पाहिजे. लोअर बॉडीचं म्हणजे कोणतं? जे सबस्टन्स आपण रेफ्रिजरेटर मध्ये ठेवतोय त्याचं टेम्परेचर काय पाहिजे? लोअर बॉडीपेक्षा ॲटमॉस्फेरिक टेम्परेचर पेक्षा कमी पाहिजे. दॅट इज आवर इंटेन्शन. सो हिअर in case of refrigerator, our focus or our intention is how much amount of heat we are absorbing. Our intention is how much amount of heat we are absorbing from a lower temperature body. And in case of refrigerator, value of T1 should be less than value of T8. Whereas in case of heat pump, रेफ्रिजरेटर कधी वापरतो आपण, एखादा सबस्टन्स आपल्याला ॲटमॉस्फेरिक टेम्परेचर पेक्षा कूल करायचा असेल, ॲटमॉस्फेरिक टेम्परेचर पेक्षा कूल करायचं असेल तर त्या ठिकाणी रेफ्रिजरेटर वापरतो. आणि हीट पंप कधी वापरणार आहे, ज्यावेळेस एखादी रूम आपल्याला ॲटमॉस्फेरिक टेम्परेचर पेक्षा पण हॉट करायचे. दॅट मीन्स इफ यू आर गोइंग टू कन्सिडर द वेस्टर्न कंट्रीज, in western countries most of the time, that means in winter season, the temperature is very much low, so there we require to heat the room. That means we have to maintain the temperature greater than the atmospheric temperature. We have to maintain the temperature greater than the atmospheric temperature. Then in that case our intention will be how much amount of heat we are rejecting. In case of refrigerator, our intention is amount of heat absorbed, whereas in case of heat pump, our intention will be how much amount of heat we are rejecting. So whatever rest of the part, that means that schematic diagram, etc., all the parts will be same. That means in case of heat pump also, there will be two bodies. First one will be called as the higher temperature body, which will have the temperature as a T2. Second one will be called as a lower temperature body, which will have the temperature as a T1. So whatever heat pump will be there, that will absorb the heat. Heat pump will be there, that will absorb the heat from a lower temperature body, and that heat will be rejected to the हायर टेम्परेचर बॉडी. त्या ठिकाणी पण काय होतं, लोअर टेम्परेचर बॉडी कडून हीट ॲब्झॉर्ब केली होती, कशाला दिली होती, हायर टेम्परेचर बॉडीला रेफ्रिजरेटर मध्ये. हीट पंप मध्ये पण काय करतो आपण, लोअर टेम्परेचर बॉडी कडून हीट ॲब्झॉर्ब करणार आहे आणि कशाला देणार आहे, हायर टेम्परेचर बॉडीला देणार आहे. बट when it is possible according to clause statement, it is only possible when we are supplying the external work. त्या ठिकाणी पण आपल्याला काय करावं लागणार आहे, एक्सटर्नल वर्क सप्लाय करावं लागणार आहे. त्या ठिकाणी पण आपण काय केलं होतं, एक्सटर्नल वर्क सप्लाय केलं होतं. आता ह्या दोन्ही डायग्राम जर बघितलं, दोन्ही डायग्राम मध्ये तुम्हाला फरक दिसतोय का, काय फरक दिसतोय का?
नो सर.
नो, फक्त फरक काय दिसतोय, ह्या ठिकाणी रेफ्रिजरेटर लिहिलेलं आहे, ह्या ठिकाणी हीट पंप लिहिलेलं आहे, एवढाच फरक. सो cycle of operation of refrigerator and heat pump will be one and same. That means refrigerator can be called as a heat pump. Only intention difference is there. So in case of refrigerator, our main focus is how much amount of heat we are absorbing, whereas in case of heat pump, our main intention will be how much amount of heat we are rejecting to the higher temperature body. So here example of heat pump I have given. In the western countries, in the winter season, the outside temperature or surrounding temperature is very much low. Suppose now surrounding temperature is suppose 10 degrees centigrade. Whether human being will feel comfortable at 10 degrees centigrade temperature, atmospheric temperature? No, that human being will not feel comfortable. So that human being will need the temperature nearly equal to suppose 20 degree, 25 degrees centigrade. But what is the atmospheric temperature? 10 degrees centigrade. So in that case, whatever heat pump we are using, what that heat pump will do, that heat pump will absorb the heat. From the lower temperature body. In that case, lower temperature body will be considered as an atmosphere. So it will absorb the heat from the atmosphere, and whatever heat that heat pump is absorbing from the atmosphere, that will be transferred to the room whose temperature we want to maintain greater than the atmospheric temperature, so or greater than the surrounding temperature. So here whatever Q1 amount of heat we have absorbed from the surrounding, that Q1 amount of heat will be transferred to the room whose temperature already we are maintaining greater than atmospheric temperature. So here T8, that is atmospheric temperature value, should be less than T2. less than T2 or T2 is greater than T8, then and then only we can call it as a heat pump. या ठिकाणी सीओपी फाइंड आउट करण्यासाठी इन केस ऑफ रेफ्रिजरेटर सीओपी कसा फाइंड आउट केला होता आपण, आउटपुट अपॉन इनपुट. या ठिकाणी डिझायर्ड आउटपुट काय होतं, किती अमाऊंट ऑफ हीट आपण ऍब्झॉर्ब करतोय कोणत्या बॉडीमधून, जी बॉडी आपल्याला कूल करायची त्या बॉडीमधून किती अमाऊंट ऑफ हीट ऍब्झॉर्ब करतोय डिवाइडेड बाय किती अमाऊंट ऑफ वर्क सप्लाय करतोय तेवढे अमाऊंट ऑफ हीट ऍब्झॉर्ब करण्यासाठी. त्यासाठी काय होतं Q1 अपॉन WR होतं. पण ह्या ठिकाणी हीट पंप मध्ये आपलं मेन इंटेन्शन काय आहे, what is the main intention in case of heat pump? What is the main intention? Can anybody tell me? Hello. आहेत का जागे सगळे?
येस सर.
What is the main intention? आपल्याला हीट पंप कधी वापरतो?
Reject the heat.
काय झालं? To reject the heat.
Reject the heat.
We are using the heat pump in case of winter season to heat the room or to maintain the temperature greater than atmospheric temperature. So here value of T2, that is here T2 will be considered, our high temperature body will be considered as a room which we are maintaining or room whose temperature we are maintaining greater than the atmospheric temperature, and that value of T2 should be greater than TA. So here if I want to calculate the COP of heat pump, if I want to calculate COP of heat pump, then what will be the value of COP of heat pump? COP of heat pump काय असणार आहे?
Q2 divided by W.
Q2 divided by W, because we are knowing that COP in general way, we are knowing that COP is nothing but desired output divided by input. What is the desired output in case of heat pump? Desired output, or our main intention or our main focus is how much amount of heat we are rejecting. So if we are rejecting the Q2 amount of heat, when it is possible to reject the Q2 amount of heat, when we are supplying the W amount of work. So here our main focus is Q2, that is desired output is nothing but Q2, and to obtain that desired output the input is nothing but W. So Q2 upon W, COP of heat pump. That COP of heat pump is also called as the energy performance ratio, EPR. COP of heat pump is also called as a energy performance ratio, that is denoted as a EPR. So COP of pump will be equal to, desired output is nothing but Q2 divided by input is nothing but work done on the pump. So Q2 divided by work done on the pump, that is nothing but WP. As we are knowing that Q2 is nothing but Q1 plus W. Q2 is nothing but Q1 plus W. So here I will get the value for W. Here I will get the value for W. What is the value for W? Q2 minus Q1 is nothing but the value for W. So COP of heat pump will be equal to Q2 divided by in bracket Q2 minus Q1. Q2 divided by in bracket Q2 minus Q1 bracket complete. Whereas COP of refrigerator is nothing but Q1 divided by in bracket Q2 minus Q1 bracket complete. आपल्याला in general definition माहित आहे COP ची. In general definition काय आहे? COP is nothing but refrigerating effect divided by work done. COP is nothing but refrigerating effect divided by work done. In case of refrigerator, refrigerating effect is nothing but amount of heat absorbed from a lower temperature body. Whereas in case of heat pump, the refrigerating effect is nothing but amount of heat rejected to the higher temperature body. So here refrigerating effect divided by work done. In case of refrigerator effect is nothing but Q1 upon work done. So Q1 upon Q2 minus Q1. Whereas in case of pump, refrigerating effect is nothing but Q2 divided by work done on the system is nothing but WP, which is equal to Q2 minus Q1. Are you getting? Yes or no?
Yes, sir.
Now, in thermodynamics, you might have studied that COP of heat pump is equal to COP of refrigerator plus 1. स्टडी केलंय का ते डेरिवेशन?
Yes, sir.
So how we are getting that COP of refrigerator, sorry, COP of heat pump is equal to COP of refrigerator plus 1. So as we are knowing that COP of refrigerator is given by equation Q1 divided by WR, whereas Q1 is called as a QA, amount of heat absorbed, and WR is nothing but Q2 minus Q1. And COP of heat pump is given by COP of heat pump, or that is also called as the energy performance ratio. COP of heat pump is also called as the energy performance ratio, that is given by equation Q2 divided by work done on the pump, whereas work done on the pump is nothing but Q2 minus Q1. Here Q2 is also called as the amount of heat rejected, Q1 is also called as the amount of heat absorbed. Now here we are knowing in the previous diagram, here you might have knowing that in case of refrigerator as well as heat pump, in case of refrigerator as well as heat pump, the value of Q2 is given by equation Q1 plus W. Value of Q2 is given by equation Q1 plus W, and value of W is nothing but Q2 minus Q1. आहे का? Q2 म्हणजे काय? Q1 plus W आहे, आणि W म्हणजे काय? Q2 minus Q1. So here now if I want to find out the correlationship between coefficient of performance for heat pump and refrigerator, so as I am knowing that coefficient of performance for heat pump is given by equation Q2 divided by Q2 minus Q1. So as I am knowing that value of Q2 is nothing but Q1 plus work done, Q1 plus work done. So here work done is nothing but Q2 minus Q1. So here if I am going to put the value of Q2 in this equation, if I am going to put the value of Q2 as a Q1 plus W, and again if I am going to put the value of W as a Q2 minus Q1, then I will get the equation as a, या ठिकाणी काय करा, Q2 ची व्हॅल्यू काय पुटअप करा, Q1 प्लस इन ब्रॅकेट Q2 minus Q1 पुटअप करा, Q1 प्लस इन ब्रॅकेट Q2 minus Q1, आणि जर न्यूमरेटर सेपरेट केला तर काय येणार आहे, Q1 divided by Q2 minus Q1 प्लस Q2 minus Q1 divided by Q2 minus Q1 येणार, आणि Q2 minus Q1 divided by Q2 minus Q1 कॅन्सल होऊन काय येणार आहे, त्या ठिकाणी 1 येणार आहे. समजते? ही स्टेप समजली का सगळ्याला? ही स्टेप आपण काय म्हणतोय, COP ऑफ रेफ्रिजरेटर म्हणजे काय, Q1 divided by Q2 minus Q1. COP ऑफ हीट पंप किंवा एनर्जी परफॉर्मन्स रेशो काय, Q2 divided by Q2 minus Q1. पण आपल्याला कशाची व्हॅल्यू माहित आहे, Q2 ची व्हॅल्यू माहित आहे. Q2 ची व्हॅल्यू काय असते, नेहमी Q1 प्लस W असते. Q2 ची व्हॅल्यू काय असते, Q1 प्लस W, आणि W ची व्हॅल्यू काय असते, Q2 minus Q1 असते. जर मी ही W ची व्हॅल्यू ह्या ठिकाणी पुटअप केली तर Q2 ची व्हॅल्यू काय येणार आहे, Q1 प्लस Q2 minus Q1 येणार आहे. हे कशामध्ये असणार आहे, ब्रॅकेटमध्ये असणार आहे. Q2 minus Q1 कशामध्ये असणार आहे, ब्रॅकेटमध्ये असणार आहे. जर मी Q2 ची व्हॅल्यू या ठिकाणी Q2 ची व्हॅल्यू ॲज अ Q1 प्लस इनसाइड द ब्रॅकेट Q2 minus Q1 पुटअप केली, आणि त्यानंतर जर न्यूमरेटर सेपरेट केला तर मला काय भेटणार आहे, COP ऑफ हीट पंप और एनर्जी परफॉर्मन्स रेशो इज इक्वल टू Q1 divided by Q2 minus Q1 plus Q2 minus Q1 divided by Q2 minus Q1, and Q2 minus Q1 and Q2 minus Q1 will get cancelled, and here I will get the value as a 1. So here Q1 divided by Q2 minus Q1, Q1 divided by Q2 minus Q1, त्यालाच मी काय म्हणणार आहे, कशाची व्हॅल्यू ही, Q1 divided by Q2 minus Q1. या ठिकाणी जर बघितलं, COP ऑफ रेफ्रिजरेटर इज नथिंग बट Q1 divided by Q2 minus Q1. So here Q1 divided by Q2 minus Q1 is nothing but the COP of refrigerator. So instead of this term, I can put the value as a COP of refrigerator. So COP of heat pump or energy performance ratio is equal to COP of refrigerator plus 1. So this is the derivation. I think for your assignment number 1, the one question is there. What is the difference between refrigerator and heat pump, and prove that COP of heat pump is equal to COP of refrigerator plus 1. So proof is nothing but this proof. किती जणांना समजते? समजते का? हॅलो, बाकीचे, कारण की ऑनलाईन लेक्चर असल्यामुळे मला पण समजत नाही, तुम्हाला नक्की समजतंय की नाही. रिमेनिंग स्टुडंट, यू कॅन गिव्ह द आन्सर. ओके, इज देअर एनी प्रॉब्लेम? कोणाला काय क्वेश्चन आहे का? असेल तर विचारा. बेस्ड ऑन द हीट इंजिन, रेफ्रिजरेटर, हीट पंप, इज देअर एनी क्वेश्चन? कोणतरी बोला अजून मधून तर. हॅलो, कोणीतरी बोला. आहेत का लेक्चर मध्ये सगळे? गेले चहा प्यायला? हॅलो,
येस सर, येस सर.
आहेत ना?
येस सर.
नाहीतर मोबाईल चालू करून खेळायला कुठेतरी, तुम्ही फिरून या जाऊन गावावर कुठेतरी. Shall we continue?
Yes, sir.
So here we require to draw this diagram. I'll give 5 minutes. So within that 5 minutes, we have to draw all the 3 diagrams: heat engine, refrigerator, heat pump. Why I am asking you to draw this diagram? Because we have to solve the problem based on this also. So now after this concept, our next point will be reverse Carnot cycle. So after studying the reverse Carnot cycle, we are going to solve the problems. So there, the basic knowledge which you require to solve the problem is nothing but this heat engine, refrigerator, heat pump. That is the basics related to this. And after that reverse Carnot cycle. So you have to draw this block diagram. Have you started to draw this block diagram? Shall I wait? Shall I wait? Question Kumar Thakre, have you completed diagram?
Yes, sir.
All the 3 diagrams?
Yes, sir.
Pen. Now itself.
तुम्ही शिकवताच काढले.
बाकीच्यांनी ड्रॉ केलेत का? वेट करायचा आहे की पुढल्या स्लाइड वरती जाऊ द्या? Okay, we'll wait for another 2 to 3 minutes. Within that, you have to draw only block diagram. Not necessary to give that 3D effect or that arrow effect. Draw that simple block diagram with the help of pen only. Don't use pencil as well as scale, because I am knowing that nobody is having that pencil as well as scale, or anybody is having that pencil, scale, eraser. माहित आहे ना काय असतं ते? आहे की नाही माहित? रेफ्रिजरेटरची जशी स्कीमॅटिक डायग्राम आहे, सेम तशी डायग्राम आहे हीट पंपची स्कीमॅटिक डायग्राम आहे. फक्त फरक काय आहे? रेफ्रिजरेटर मध्ये काय करतोय आपण, T1 चं टेम्परेचर लेस दॅन T8 ठेवतोय, ऍटमॉस्फेरिक टेम्परेचर पेक्षा कमी ठेवतोय. आणि ह्या ठिकाणी T2 चं टेम्परेचर ग्रेटर दॅन ऍटमॉस्फेरिक टेम्परेचर ठेवतोय. एवढाच फक्त फरक आहे रेफ्रिजरेटर आणि हीट पंप. आणि ह्या ठिकाणी WR ची व्हॅल्यू पुटअप करताना, या ठिकाणी WR ची व्हॅल्यू काय पुटअप करताय? Q2 - Q1. ते फक्त ब्रॅकेट मध्ये घ्या. इन ब्रॅकेट Q2 - Q1 ब्रॅकेट कंप्लीट. ह्या ठिकाणी पण WP ची व्हॅल्यू इन ब्रॅकेट Q2 - Q1 ब्रॅकेट कंप्लीट लाईकवाईज. कोणती लेक्चर चांगले वाटतात? बाकीचे डायग्राम ड्रॉ करेपर्यंत ज्यांचे झाले त्यांनी ते करा, डिस्कस करा. म्हणजे ऑनलाईन लेक्चर चांगले वाटतात की क्लासमधले समजण्याच्या दृष्टीने? ठाकरे, तुझा कुकर झालं खेळताना अत्रे क्लासमध्ये या ठिकाणी प्रॉब्लेम काय येतो सांगू शकता ऑनलाईन मध्ये, जेणेकरून त्यामध्ये इम्प्रुव्हमेंट करता येईल.
ऑनलाईन मध्ये तुमचा आणि गिड्डे सरचा चांगला
हा.
क्लास होतो. चांगला
ते
क्लास
नाही
होतो.
ओव्हरऑल विचारतो मी, म्हणजे तुम्ही जर ऑनलाईन आणि क्लासरूम या दोन्हीमध्ये जर कम्पॅरिझन केलं तर दोन्हीमध्ये तुम्ही म्हणताय क्लासरूम बेटर आहे, तर कशामुळे म्हणताय, म्हणजे नक्की प्रॉब्लेम काय होतोय क्लासरूम मध्ये असल्यानंतर, प्रेझेंट असल्यानंतर आणि ऑनलाईन मध्ये दोन्हीमध्ये फरक आहे?
तुमचं इंटरॅक्शन होतंय, तुमचे हावभाव समजतं
हावभाव समजते.
शिकवताना. हा,
अजून नेटवर्क प्रॉब्लेम, प्रॉब्लेम.
नेटवर्क प्रॉब्लेम. हा, सर जे लेक्चर शिकवलेले आहेत ते रेकॉर्डर आले पाहिजे.
रेकॉर्ड करतोय आपण, ते फक्त लिंक तयार केलेली आहे, म्हणजे एक्सेल शीट तयार केलेली आहे, त्यावरती फिलअप करून घेऊन तुम्हाला लिंक एक शेअर करतो. त्या लिंकवरती क्लिक केलं ज्या पण वेळेस तुम्हाला लेक्चर ऐकायचे असतील त्यावेळेस हे जे काय आपण रेकॉर्डिंग केलेले लेक्चर आहे ॲज इट इज तुम्हाला ऐकू येईल.
येस सर.
Have you completed this? Everyone? Shall we proceed further?
Yes, sir.
Okay. So here you have to write down this derivation part also. Write down as it is. Not necessary to explain once again. COP of refrigerator is equal to Q1 upon WR. WR की value put up करा. COP of heat pump or EPR. EPR तो लॉन्ग फॉर्म लिहून ठेवा नोटबुकच्या वरच्या साईडला. एनर्जी परफॉर्मन्स रेशो, कारण की एक्झाम मध्ये काही वेळेस हीट पंप, सीओपी ऑफ हीट पंप विचारायच्या ऐवजी काय म्हणतात, फाइंड आउट दी ईपीआर ऑफ हीट पंप. Have you completed? Yes or no? No. Shall we proceed further? Reply करते जाऊन इथं. ओके. सो झाले का सगळ्यांचे?
Yes, sir.
थांबायचं अजून 1 मिनिट.
No.
तर 5 लाईन आहेत. Have you completed? Okay. Now next concept is called as a reverse Carnot cycle. So actually we are starting our chapter number 1. That means whatever basic cycles are there, the chapter name is basic refrigeration cycle. So whatever various basic refrigeration cycles are there, out of that first basic cycle of the refrigeration system is called as a reverse Carnot cycle. It's called as a reverse Carnot cycle. So up till now you have studied various cycles, so you are knowing how to analyze those various cycles. So by using the PV and TS diagram, by using the PV and TS diagram, you are able to analyze the various cycle. So you are also knowing that area under PV diagram, area under PV diagram, by using the area under PV diagram, you are getting the, what you are
Work done.
getting by using the area under PV diagram, work supplied to the system or work obtained from the system. Work supplied to the system or work obtained from the system is given by area under PV diagram. Whereas area under TS diagram, TS diagramच्या अंडरचा एरिया घेऊन तुम्हाला काय मिळतं? What you are getting by using the area under TS diagram? आता मुस्कान आता Pratikesh Kumbar.
हाँ सर.
Area under TL diagram. What you are getting?
Work done.
आणि area under PV diagram. कशासाठी PV आणि TL diagram कशासाठी ड्रॉ करते? परीक्षेत 5 मार्क मिळवण्यासाठी फक्त डायग्राम सफिशियंट नसते. PV आणि TL diagram काढली म्हणजे सफिशियंट झालं 5 मार्कासाठी. यासाठी आहे का? For what purpose we are drawing the PV and TL diagram? So, Ambire, for what purpose we are using the TL diagram? So by using the area under TL diagram, we are able to calculate how much amount of heat is supplied to the system or how much amount of heat is being rejected from the system. So always here afterwards, always you have to keep in mind that area under PV diagram, you will get the work supplied or work obtained, and area under TL diagram, you will get that amount of heat supplied or amount of heat obtained. So as we have seen, as we have said that refrigerator is nothing but a reverse of heat engine. As we have seen that or said that refrigerator, in the previous slide itself, we have seen that whatever refrigeration process is there, that is exactly reversible as that of heat pump. So not heat pump, exactly reversible as that of heat engine, and that's why we are calling refrigerator is nothing but the reverse of heat engine. So you have studied in case of IC engine or in the subject internal combustion engine, you have studied the standard cycle on the basis of which that heat engine works is called as a Carnot cycle. The Carnot cycle is called as a standard cycle or the basic cycle on the basis of which that heat engine always works. So as refrigerator is the reverse of heat engine, as refrigerator is reverse of heat engine, hence the standard cycle or the basic cycle on which any refrigerator can work is nothing but the reverse Carnot cycle. Is nothing but the reverse Carnot cycle. कारण की हीट इंजिनला रेफ्रिजरेटरला काय म्हणतो आपण रिव्हर्स ऑफ हीट इंजिन म्हणतो. हीट इंजिनची सायकल कोणते कॅर्नॉट सायकल आहे. जर रेफ्रिजरेटरला रिव्हर्स ऑफ हीट इंजिन म्हणत असेल तर रेफ्रिजरेटर वर्क होणारी सायकल जी असणार आहे ती कोणती असणार आहे रिव्हर्स कॅर्नॉट सायकल म्हणतात. Also you are knowing that in case of heat engine, the maximum efficiency of heat engine is obtained. The maximum efficiency of heat engine is obtained by using the Carnot cycle. Then also not a single heat engine is there which can work on the, or actually not a single heat engine is there which can work on the Carnot cycle. Why? Because there are some practical limitations of Carnot cycle. कुणाला माहित आहे का प्रॅक्टिकल लिमिटेशन्स काय आहेत Carnot सायकलचे? ते तर माहिती आहे की हीट इंजिन मध्ये बेसिक सायकल जे आहे त्याला Carnot सायकल म्हणतो, हे माहिती आहे?
येस सर.
त्यानंतर हे माहिती आहे की हीट इंजिन सगळ्यात जास्त इफिशियन्सी ऑफ हीट इंजिन जर कशात भेटत असेल आपल्याला तर ते कशामध्ये भेटते Carnot सायकल मध्ये भेटते. पण एकही हीट इंजिन असं नाही की जे Carnot सायकल वरती वर्क होते. त्यासाठी परत त्या Carnot सायकल मध्ये मॉडिफिकेशन करून आपण काय केले ऑटो सायकल, डिझेल सायकल, ड्युएल सायकल. ऑटो सायकल, डिझेल सायकल, ड्युएल सायकल हे कशाचे मॉडिफिकेशन आहे रिव्हर्स Carnot सायकलचे मॉडिफिकेशन आहेत जेणेकरून जे काही प्रॅक्टिकल डिफिकल्टी होत्या Carnot सायकलच्या प्रॅक्टिकल डिफिकल्टी ज्या काय होत्या त्या काय केलेले रिमूव्ह केलेले आणि प्रॅक्टिकल डिफिकल्टी रिमूव्ह करून त्या Carnot सायकलचं आपण कशामध्ये कन्वर्जन केलेलं आहे प्रॅक्टिकल सायकल्स मध्ये कन्वर्जन केलेलं आहे. त्याच म्हणजे कोणते ऑटो, डिझेल, ड्युएल सायकल. सो कॅन एनीबडी टेल मी what was the practical difficulties of Carnot cycle?
Impossible.
Ideal cycle. It is ideal, sir.
It is ideal.
Carnot cycle is
Carnot
ideal.
cycle is a ideal cycle. Okay. but 5 it is ideal cycle.
Sir, Carnot cycle is consisting of isentropic and isothermal
Oh.
process. One of it is very fast and one of it is very slow.
Okay.
That's why it is impossible.
Exactly. So Carnot cycle, whatever Carnot cycle is there, that is consisting of two isentropic processes and two isothermal processes. So for occurring that isentropic processes, we require the very high speed. And to obtain the isothermal processes, we require the very low speed. So with the help of working fluid as a gas or liquid, it is not possible to uh, instantly transfer from higher speed to the lower speed, and hence that Carnot cycle remains as a ideal cycle only. In practical application, we are not using the Carnot cycle, though it is having the highest possible efficiency. Similarly, in case of refrigerator, the working cycle or the basic cycle or the standard cycle on which a refrigerator works is called as a reverse Carnot cycle, because a refrigerator is called as a reverse of heat engine. In case of refrigerator, the highest possible efficiency, आता efficiency word यूज करू शकतो का रेफ्रिजरेटरच्या बाबतीत? इफिशियन्सीच्या ऐवजी कोणता वर्ड यूज करतो आपण रेफ्रिजरेटरच्या बाबतीत? COP. So in case of refrigerator, the highest possible COP is obtained for the reverse Carnot cycle. In case of refrigerator, the highest possible COP is obtained in case of refrigerator. In case of refrigerator, the highest possible COP is obtained in case of a reverse Carnot cycle, but similar to heat engine. In case of refrigerator also, it is not possible to design a device which can work on a reverse Carnot cycle practically, because here also there are some practical limitations of reverse Carnot cycle. So though the reverse Carnot cycle is having highest possible COP, then also it is used as a standard cycle only, or standard for comparison only. It will not be used practically, because this cycle are having practical limitations. Are you getting? So reverse Carnot cycle is a standard cycle which can be used for standard of comparison only. It cannot be used practically because it is also having the practically difficulties. Are you getting this point? Yes or no? Yes or no? So here the reversing the Carnot cycle does reverse the direction of heat and work interaction. So refrigerator or heat pump that operates on a reverse Carnot cycle is called as a Carnot refrigerator or Carnot heat pump. That means if any refrigerator or heat pump is working based on the Carnot cycle, that will be called as a Carnot refrigerator or Carnot heat pump. As like Carnot cycle, though reverse Carnot cycle has highest possible COP, then also it is not possible to make a refrigerator which will work on a reverse Carnot cycle. That already I have explained. So hence reverse Carnot cycle is used as the ultimate standard of comparison. That means it will not be used practically. It is used only for standard of comparison. Now whatever reverse Carnot cycle is there, that is consisting of 4 processes. Whatever reverse Carnot cycle is there, that is consisting of 4 processes. Out of that, first process, so here you can see the schematic diagram. So here this is the compressor. So whatever reverse Carnot cycle I am showing to you, so that reverse Carnot cycle using air as a refrigerant. I am showing this reverse Carnot cycle by using air as a refrigerant. So this is the first compressor. Inside the first compressor, Inside the first compressor, whatever air will be there, which will be coming out of the evaporator, that air will be compressed inside the compressor, and that compression process will be the isentropic compression process. So whatever first process which will be occurring inside the compressor will be there, that will be called as the isentropic compression process. So here inside the isentropic compression of air will take place isentropically. So that compressed air will be supplied to the another compressor. So this is again another compressor. Here air will be again compressed, but here whatever air is compressing, that compression will be isothermal compression heat rejection. So whatever 2 to 3 process will be there, whatever 2 to 3 process will be there, that will be called as the isothermal compression. First one is the isentropic compression. Second one is called as the isothermal compression. Then after isothermal compression, the same air will be given to the expander, but that is also called as the turbine. Same air will be provided to the expander, that is also called as a turbine. Where that air will be compressed, where that air will be expanded isentropically. So 3 to 4 process will be the isentropic expansion inside the turbine or expander, and same air will be supplied to the expander, that is also called as the turbine, another turbine. So here inside the turbine or expander, that process will be the isothermal expansion heat addition process. कारण की आपल्याला काय माहित आहे, आयसेंट्रॉपिक प्रोसेस मध्ये आयसेंट्रॉपिकच्या बरोबर कोणता वर्ड असतो, फक्त एकतर कॉम्प्रेशन किंवा एक्सपान्शन वर्ड असतो, त्याबरोबर हीट ऍडिशन हीट रिजेक्शन येत नाही. कारण की आयसेंट्रॉपिकचा अर्थ काय, रिव्हर्सिबल ॲडियाबॅटिक, आणि ॲडियाबॅटिक म्हणजे नो हीट विल बी ॲब्झॉर्ब, नो हीट विल बी रिजेक्टेड. So whatever 1 to 2 process as well as whatever 3 to 4 process is there, that will be the isentropic compression, isentropic expansion process. Here during 1 to 2 process, no heat will be absorbed or no heat will be rejected. During 3 to 4 process, no heat will be absorbed or no heat will be rejected. But 2 to 3 process and 4 to 1 process, those processes are isothermal processes. So along with isothermal, if compression will be there, because only isothermal compression or only isothermal expansion is not possible. So compressing by keeping the temperature constant, it is only possible when we are rejecting the heat. So along with isothermal compression, word is heat rejection. So 2 to 3 process is nothing but isothermal compression heat rejection process. And whenever we are expanding isothermally, so only isothermal expansion is not possible. Along with that, there should be the heat addition. So 4 to 1 is nothing but isothermal expansion heat addition process. So this is the diagram of reverse Carnot cycle, and the reverse Carnot cycle consisting of 4 processes. Reverse Carnot cycle consisting of 4 processes, out of which 2 are isentropic processes. Out of which 2 are isentropic processes and remaining 2 are isothermal processes. Carnot cycle मध्ये पण किती प्रोसेस होत्या, Carnot cycle मध्ये किती प्रोसेस होत्या, 4 प्रोसेस होत्या, आणि त्यातल्या 2 कोणत्या होत्या, आयसेंट्रॉपिक होत्या, आणि 2 कोणत्या होत्या, आयसोथर्मल होत्या. सिमिलरली रिव्हर्स Carnot cycle मध्ये पण किती प्रोसेस असणार आहेत, there will be again 4 processes only, out of which 2 processes will be isentropic processes, remaining 2 processes will be the isothermal processes. So which are those processes? So process 1 to 2, what is the name of that process? What is the name of process? So process 1 to 2 is occurring inside the compressor, and that compression is nothing but isentropic compression process. So here process 1 to 2 is nothing but isentropic compression inside the first compressor. Outlet of compressor will be given or will be again supplied to the another compressor, whereas inside the another compressor the same air will be compressed, but that same air will be compressed isothermally with heat rejection. So 2 to 3 will be isothermal compression heat rejection process, isothermal compression heat rejection process. Then outlet of this second compressor will be provided to the expander or turbine, whereas 3 to 4 process, will occur inside the turbine, or that is also called as the expander. That 3 to 4 process is nothing but isentropic expansion process. 3 to 4 process is nothing but isentropic expansion process, and here outlet of isentropic expansion, that means whatever air is expanded isentropically, same air will be again supplied, or same air will be again passed through the expander, whereas inside the expander whatever expansion process, further expansion process will be carried out, that further expansion process will be carried out isothermally. But that isothermal expansion, along with that there will be the heat addition. So isothermal expansion heat addition process will be there, that will be called as a 4 to 1 process. Are you getting? Yes,
Yes,
or
sir.
no? Now here you are knowing the 4 processes, all the 4 processes. So based on all the 4 processes, whether it is possible for you to draw the PV and TS diagram for reverse Carnot cycle. We have seen the basics, how to draw the PV and TS diagram. बेसिक बघितले आपण, बघितलंय की नाही? Yes or no? So based on the basics, whether it is possible for you people to draw the correct PV and TS diagram for reverse Carnot cycle. Whether it is possible, सांगा कोणतरी एकानं, होय किंवा नाही? आहे का पॉसिबल? आहे का सगळे? हॅलो, hello, am I audible? Hello. So whether it is possible to draw the PV and TS diagram. So this will be the task before starting our next lecture. So I think now time is 2:28. That means for starting of your next lecture 2 minutes is remaining, and I think Pomne sir has already shared the link for his lecture. So now we are going to stop here. I have recorded your attendance also. So before starting of our next lecture, now only you have to write down this 4 process name: isentropic compression, isothermal compression heat rejection, 3 to 4 isentropic expansion, and 4 to 1 isothermal expansion heat addition process. I have written these 4 names. So by using this 4 names, you have to draw the PV and TS diagram for reverse Carnot cycle. And before our next lecture will be tomorrow. So before our tomorrow's lecture, you have to send me whatever drawn PV and TS diagram. That PV and TS diagram you have to send me on my WhatsApp number. You can send that on my WhatsApp number. I will check. So this will be your homework. Are you getting? But don't use the book. All of you, please pay attention. Don't copy from anyone else. So I am asking you to draw the PV and TS diagram to judge your knowledge only. I am not going to demoralize you. I just want to know what is your understanding level. So as I have explained how to draw the PV and TS diagram. So based on that knowledge only, you have to draw that PV and TS diagram. So only by looking to this 4 cycle, you have to draw the PV and TS diagram. Don't refer any book, don't refer any notes while drawing that PV and TS diagram. And after drawing that PV and TS diagram, take the screenshot or take the photograph and send me on my WhatsApp number. Thank you. Now you can leave my lecture.